YouTube channel. So today the topic we are going to discuss is apoptosis, which is a main essay question. I have divided the question into two parts. First I will be telling you these two subdivisions, and one more subdivision is there that I will explain later. Okay, so without any further ado, let's start with our session today. So let me read out the question. Define apoptosis with examples and describe the morphology and biochemical changes in apoptosis. So we are going to discuss about the definition of apoptosis and examples and the morphology and biochemical changes associated with apoptosis. So let's get into the topic. First and foremost, the definition. So the definition might seem a bit big, but let me break it down for you. Apoptosis is a pathway of programmed cell death. What is it? It is a type of programmed cell death induced by tightly regulated suicide program. It is characterized by the activation of intrinsic enzymes of the cell itself that degrade its own nuclear DNA and proteins. So, apoptosis is nothing but it is a type of cell death, which is programmed cell death, which can be induced by the tightly regulated suicide program. It has its own intrinsic enzyme that will degrade its own contents, that is DNA and proteins, that is apoptosis. So while learning, I had this doubt why it was called programmed. It is called programmed because cell is actively participating in its own death by following a genetically controlled and highly regulated sequence of events. Nothing, it's just actively participating in its own death, that's why. Now, this is a definition number 2 I have written. It's just not easy to remember. I took it from Robbins. If you are forgetting the original definition, I think you can remember a bit of this definition. It's the same meaning only. It is a regulated mechanism, programmed cell death, of cell death that serves to eliminate unwanted and irreparably damaged cell with the least possible host reaction. It is a caspase dependent mechanism. Okay, so it's up to you if you want to study this definition, but the first definition is also easy, right? So I think we can go with the first definition only. Now, examples. Our second subdivision was the examples, right? So while giving examples, apoptosis is both physiological and it is also pathological. Now let us discuss few of the examples from physiological aspect. Physiologically, it is removal of excess cells during embryogenesis. So when the baby, when we are embryo, there will be increased apoptosis. It is natural, it is physiological, it's okay. Okay. Second thing is in developmental processes. Example, disappearance of web tissue between fingers and toes. I will try to add a picture over here. That means this will be the fingers, right? So in babies or in the fetus, it will be webbed at first. So it is through apoptosis that this webbed skin is getting it is reducing, and we are having our beautiful hand. Just ignore this image. I will give it a nice image over here. Now, third will be the elimination of hormone dependent cells after the withdrawal of hormonal stimulant. Let's not make it complicated, it's just endometrial breakdown during menstrual cycle. Third is the regression of lactating breast after withdrawal of breastfeeding, and fourth will be the cell turnover in proliferating cell population. So it will be better if you study 3 examples thoroughly by heart, and it's very easy only, right? If I'm gonna write the exam and I will be remembering, one will be the physiological, the embryogenesis thing, second will be the disappearance of web tissue, third will be the endometrial breakdown. This will be the 3 things that I will be remembering during exam time. So yeah. Now let's move on to the pathological. Pathologically, apoptosis eliminates cells that are generally altered or damaged beyond repair. So something is not needed at all. So this apoptosis is eliminating those cells. That's it. So in pathologically, it will be like elimination of mutant cells with damaged DNA. Something that is mutant, it won't be good, right? So eliminating that, apoptosis is helpful. Destroying cells with dangerous mutations or with DNA damage beyond repair. By doing this, what is apoptosis helping with? It prevents the development of cancer. So it is not inducing. So see, it is not promoting the growth of the mutant cells. It is trying to eliminate it. So by eliminating it, it prevents the development of cancer. Now, there will be the elimination of cells with excessively accumulated misfolded protein, which is also not good. So apoptosis is going to eliminate those things. And also the killing of viral infected cells. The infected cells are lost mainly due to apoptosis, either induced by the virus or by the host immune response itself. By virus means HIV, etc. By host immune responses, it's a viral hepatitis, etc. Okay, now we have come to our third subdivision, which is the morphology and biochemical changes happening in the cell during apoptosis. So let's study about the morphological changes that's going to happen. So we are going to see the cell through an electron microscope. So what and all we can see? We can see the cell is getting very shrinked. Cell shrinkage can be seen. That is, cell size is reduced, cell is becoming more dense, cytoplasm is becoming more dense, and it will be more pink in color. Pink means it is eosinophilic, becoming more eosinophilic. Now, second change will be chromatin condensation, also DNA fragmentation. It is the most characteristic feature. It is something that you can definitely see in a stain, or we can see in an electron microscope. Now what happened, suppose this is cell, the chromatin get aggregated peripherally under the nuclear membrane. And also DNA fragmentation, there will be fragmentation happening. Third point will be formation of cytoplasmic bleb formation will be there, and apoptotic bodies also will be there. What is apoptotic bodies? That I will discuss in a next question. I will be discussing what is apoptotic bodies. Yeah, okay. Now fourth point will be phagocytosis of apoptotic cells or the bodies will be, we can see it clearly, phagocytic cells we can see. Now in light microscope, if you are seeing, we can see apoptotic cells are round or oval mass. It will be very eosinophilic and there will be no inflammation reaction in the host. Okay. Now let's move on to the biochemical changes. Okay. So biochemical changes, what's happening during apoptosis? First, there will be activation of caspases. So you won't be understanding what these are now. I'll be taking another session, not about these biochemical changes. It will be about the mechanism. So while teaching that only, you will be understanding what these column means. So after watching this video, after writing this lecture, you can go and watch the next video, and after watching this and while you are reading this, you will understand what I am saying now. Okay. First will be the activation of caspases 8, 9, 10, then 3, 6, 7. You will it will be quite confusing for you now. As I said, you will understand it. Second will be DNA fragmentation, of course, because endonuclease will be acting. It will cleave the DNA into the fragments, and there will be protein degradation. This is my abbreviation for protein. So it's a protein degradation will be there, and there will be altered membrane lipids. There will be flipping of phosphatidylserine. You won't be understanding this now. I'll teach you in the next class. Now mitochondrial changes, there will be loss of mitochondrial potential and there will be release of cytochrome C. This also in the next class, maybe like next video. And sixth one will be the role of BCL2 family. Anti-apoptotic factors are BCL2, BCXL, and pro-apoptotic factors are BAX and BAD. Okay. That's it for today's video. Thank you for watching and stay tuned for the next videos. Thank you.